All right, our next and final speaker is Illyoung Choi of CyVerse and University of Arizona, and he will be talking about connecting data to the interactive apps in CyVerse Discovery Environment via iRODS CSI Driver.
Thank you. Hi, I am Illyoung Choi from CyVerse, University of Arizona. In this presentation, I will be talking about iRODS CSI Driver integration to CyVerse Discovery Environment. Discovery Environment is a cloud service that provides computing resources and apps for scientific research. The Discovery Environment runs apps on a Kubernetes cluster. Apps can access data from various sources, such as S3 and FTP. However, data store is the most used data source as it is an internal data storage service run by CyVerse. The data store is built on top of iRODS, and it is integrated to Discovery Environment to provide accessibility. Let's take a closer look at the integration. Previously, we used data staging method to provide access to the data store in the Discovery Environment. This method used local disks as a temporary space for input and output. So input data should be downloaded to local disks, and output data should be uploaded to iRODS before and after running apps. Data staging is probably the most widely used data access method in scientific computing. However, there are several known issues in this method. First, it requires a long time to launch apps with large input data due to increased time for data staging. Second, it requires disk space to make copies of input data. If input data is large, then it needs the same size of local disk space as well. This makes it challenging to run an analysis with terabytes of data that exceeds available local disk space. Third, apps cannot access to data stored in data store other than user-selected input. This is because only user-selected input data are copied to local disks. Of course, data can be downloaded to local disks using I commands later, but this is manual process. To solve the problems in the discovery environment I mentioned before, we used iRODS CSI Driver. The iRODS CSI Driver is a Kubernetes storage driver for iRODS. Using the driver, we can create Kubernetes persistent volume for iRODS. Internally, the driver uses iRODS Fuse Lite of iRODS file system client. This client allows users to mount iRODS data on the file system in pods, so that apps running in the pod can access iRODS data via the file system mount as if they are in local disks. iRODS data are transferred on demand as apps access the data via the file system mount. There are several advantages in using the iRODS CSI driver in the discovery environment. First, launching time of apps became very quick. It takes only 20 seconds, regardless of input data size. Previously, this took minutes to several tens of minutes, depending on input data size. Second, apps have full access to data store. the discovery environment provides access to 4 different data. First is user-selected input data, and then second is auto-created output directory for the analysis. Third is user's home directory in data store. And fourth is the community shared data sets. So they have nearly full access to the data store. Lastly, output data of apps are immediately sent back to a data store while the apps are running. So other apps or services can find them and pipelining the data processing. Then how we integrate the iRODS CSI driver to the discovery environment. When a user launches an app in the discovery environment, a service called App Exposure creates a Kubernetes persistent volume using the iRODS CSI driver. Then it creates a Kubernetes pod for the app here. The persistent volume creation request is sent to iRODS CSI driver to control iRODS Fuse Lite that runs inside of the CSI driver pod. The iRODS Fuse Lite is the one providing actual data access to iRODS through the file system. To sum up, the integration requires only few lines of code to create Kubernetes persistent volumes with proper parameters. The app exposure creates persistent volume and persistent volume claim object. After the app runs, it also deletes them. We configured the iRODS CSI driver to use proxy authentication so that it does not require user password for authentication during the persistent volume creation. We created only one persistent volume and persistent volume claim per app. This means only one iRODS Fuse Lite process is created for mounting 4 different data sets as listed below. Having just one process is advantageous as it can share iRODS connections and cache between the mounts. This is possible by using a new feature called a custom path mapping that is built in iRODS Fuse Lite. This feature allows mounting 4 different data sets as a subdirectory in a root directory of the mount. And then we also gave different data access permissions here. We deployed the integration into production earlier this year, and we encountered several issues. Some users of RStudio and Jupyter Lab reported that they cannot find their data in the working directory. Obviously, the data store data was mounted on a different directory, but the user were not familiar with the Linux terminal commands, so they could not access them. So we decided to create symbolic links under the default working directory of those apps so that they cannot miss them. There also was an issue that too many iRODS connections were created. This was because a user created several apps simultaneously, and those apps accessed many files at the same time. So we developed a new service called iRODS Fuse Lite Pool Server and then built it, embedded it into the CSI Driver. This service manages connections and share connections between iROD fuse light processes. There were also file system compatibility issues. For example, Git clone failed due to file renaming. Linux file system allows renaming open files. However, this is not supported in iRODS, so this caused the failure. We applied a patch of it to Go iRODS client, which is a base iROD library. And then that library is used by iROD Fuse Lite. So we made a patch of it. The patch is about closing open file handles before the renaming the actual file, and then renames the file and then reopens the file handle afterwards. The patch is pretty simple, and it worked pretty well. Similarly, RStudio and VI editor failed due to the file truncation. They used ftruncate command, which is not supported in iRODS. Also, it sometimes used otrunc option when opening a new file, which is not currently supported in iROD Fuse Lite. This is because its base Fuse library does not support it. We also made a patch for the issue using the similar solution. Closing the file handle first and then do the actual process using another APIs supported by iRODS, and then reopening the file handle afterwards. We also applied some performance optimizations to improve user experience of the discovery environment. We observed that RStudio and JupyterLab keep checking files and directories in the working directory. So they repeatedly cause directory listing and file information retrieval calls. To respond quick, we added metadata caching to the iROD Fuse Lite pool server. Then it caches metadata for 5 minutes, and then metadata for community data sets seldom change, so it has 1 hour of expiration time. To improve data I/O performance, we also implemented asynchronous writing and prefetching and data caching in the iROD Fuse Lite pool server as well. So currently, all the performance optimizations are applied to iROD Fuse Lite pool server side. Let's see the I/O performance of the CSI driver. Because iROD CSI driver uses iROD Fuse Lite for data access, the performance of iROD Fuse Lite is same as the performance of iROD CSI driver. The iROD Fuse Lite in yellow showed reduced I/O bandwidth comparing to other iROD clients here, especially for download. This is because iROD Fuse Lite transfers data on demand. Other iRODS clients used in the benchmark does not transfer data on demand. They transfer whole data files sequentially. This is why iROD Fuse Lite showed reduced I/O bandwidth, because it requires a lot of request response exchanges. Nevertheless, we think we can improve the performance of the iROD Fuse Lite a bit more, at least close to SFTP Go, the red one. So we continue to optimize the code these days. we share the source code of the iRODS CSI driver, iRODS fuse light, and the iRODS fuse light pool server publicly via GitHub, so you can find the source code of them. And we also share the integration code that is in the app exposure source repository. To conclude, we integrated the iRODS CSI driver into a CyVerse Discovery Environment and released in production earlier this year. Overall, users were satisfied with data accessibility, and there were no critical issues reported, while we observed several less critical issues. We encountered unexpected file system compatibility issues, and we fixed them successfully so far. We are also trying to improve I/O performance of the iRODS CSI driver these days. Yep. Thank you for listening. And do you have any questions?
All right. Thank you. Are there any questions for Illyoung? You have a question?
I just want to point out that Mike Conway has a comment on the Slack general channel about a project or an implementation called Hatchery. So anyone interested in that, please read that comment.
All right. I have a question. Illyoung, is there anything in the iRODS server that would help simplify this implementation or the CSI driver?
The simplification?
Yeah, like is there anything that we can do in the iRODS server that you would like to see changed that would help with this implementation?
Yeah, actually the ftruncate API is the one I need. Yeah, that's the one I really want.
Okay.
Yeah, I already asked it previously. Yeah, but yeah. And actually the other file system compatibility issue is very common for all other in any remote data storage systems. So I think, yeah, that's common. So yeah, the workaround I made is very, straightforward, and that is, yeah, unavoidable, I think.
Okay. All right. Well, thanks, Illyoung.
Thank you.
Mhm.